In June 2014, our group made it down to the Maroi Conservancy in the Limpopo province. Maroi Conservancy is located in the Limpopo Valley, right next to the Limpopo River. In the first 2 days of being at Maroi Conservancy, we started out by setting up a small lab inside the house. We learned more about the anatomy of the metatarsal glands by dissecting impala legs. We learned that the substance inside the gland had a distinct smell and that being inside the room for more than 15 minutes proved to be overwhelming. We also found that the pheromone is excreted under muscular contraction. We then proceeded to the first part of the experiment, where we obtained negative results by studying the general movements of the impala. We also used this as an opportunity to see when the impala were less active during the day so that we could move in around that time and collect data without causing any disturbances. 3 areas were selected based on fresh tracks and dung heaps. Experimental procedures began as we got up early every morning to start removing glands from the impala legs. By midday, when the impalas were less active due to the heat of the day, we moved in to place glands in the trails. The glands were attached to trees and the extracts were put on rocks along the trails. Data was collected every day as fresh glands were being put in place. The impala showed absolutely no reaction towards the glands, and they just strolled right past them every day. The glands did, however, have a smell to them because the mongoose came and stole some of our glands, which also ended up implicating our study. In the first part of our study, we came to the conclusion that the impala would not have reacted to the diversions that we created by experimentally creating a scent trail that would confuse them or alter their behavior in terms of their normal movements along the walking trails. The reason for this could be that, despite using sterile methods and fresh glands, the gland is only important in terms of behavioral changes when in actual stressful situations. We could also keep in mind that the pheromone is excreted by muscular contraction when running. Thus, the scent or situation that we created could have no effect on their movements on the trails. Based on the findings of the previous experiment, we decided to take the next step in seeing the behavior of the impala when subjected to actual stress situations. Alicia and myself returned to the Limpopo Valley in August 2014 to take on the next part of this experiment. The first stressor was applied using a spotlight to temporarily blind the impala. We drove around late at night and documented the results using a video camera. When blinded, impalas feel vulnerable and tend to make high, undirected leaps into the air until they reach the dense cover. There seems to be a form of communication between them as they leap in an attempt to get away from the stressor. So we're in this beautiful place in the Limpopo Valley, and our impala study, behavioral study, actually our hypothesis and what we are doing is, it has to do with the hind leg gland of the impala. It's called the fetlock gland, and what we do is with the project is about predators and how impalas use these glands when they run away from predators. So when a predator chases an impala, what it does is that what they do is the whole bunch of them, they scatter up and they split up, and while running they actually jump into the air, kicking their hind legs into the air and excreting a substance from this gland at the back of their legs, the metatarsal gland, and to find each other again, to regroup after being chased by a predator or being chased by us in this instance. What we'll do today is we'll actually load a bale of lucerne or alfalfa off at one of the feeding points, and then tomorrow morning or tonight, depends when they come in, we'll actually just from there chase them off again and see their movement patterns from a kopje. Okay, today when we chased them from the kopje and we actually saw them running away and kicking up into the air, something we saw that was different today of their behavior was that they regrouped and actually stopped inside the brush. As soon as they got to cover, they stopped running and they regrouped. Everyone got together, where from there they started walking on slowly. On top of the dam wall, we just saw a group of impala, and what we're going to do is we're going to climb a rocky outcrop, a kopje, and from the top we'll try and follow them from there, and then hopefully we can get some more footage from the top of the kopje of them running.
Impalas are unique in having what is called metatarsal or fetlock glands. These tufts of black hair at the base of an impala's hind legs play a major role in their success in nature. Impalas are the prime food source for large predators, and so it should make sense that they are well equipped to run for their lives. What separates them from other animals, however, is how the whole herd moves as one at full pace through the bush as they clear obstacles with jumps of up to 3 meters high. The gland comes into action when they secrete a pheromone under muscular contraction, and running stimulates this release. As we have seen in this study, the front runners leave a central from the metatarsal gland that follows the paths of their hind legs. As the back runners hit the central with their noses, an autonomic nervous response kicks in, and they jump as well.